So the topic for the next session are functions. And as I said earlier, functions are quite important because they really let you structure your code. So far, we've seen basic MATLAB functionality, so different variable types that you can address and index and exchange things and do little computations on. And then in the last session, how you can also write code that is more dynamic, so you can iterate through code and use if statements to not always do the same thing, but sometimes do something different depending on some conditions and so on. But essentially, so far, when you would write an M file, you would just put in a lot of code from top to bottom, and each line of code would be executed one after the other, and there's not that much of logical organization of code. And functions allow you to put code that does a specific thing together, and then allows you to use this code in other functions that might do different things, but need to use the same operation. So we've seen, of course, functions before. So everything that we looked into in terms of MATLAB commands. So, for example, we've seen sum, for example. These are inbuilt MATLAB functions. So you can look actually at the code that MATLAB executes when using these functions, using edit. Some of these very basic functions, there you won't find any MATLAB code because they are compiled C routines. So you need to do a little bit more to actually look at the code. But for other MATLAB functions, I don't know which one. This is also fairly compiled. Will I find something? Maybe I should see the code. Yeah. So this is an example, so subplot for making subplots, where you can look at the MATLAB code that is behind this MATLAB function. Yeah. So whenever we used some kind of command and applied that somewhere, we used a function. And then most of the code in MATLAB, the function code is written in MATLAB code, so you can look at that. And the nice thing that beyond using these inbuilt functions, you can create your own functions. And how to create your own functions, this is what we want to talk about now. It helps to associate with the programming concept of a function also the mathematical concept of a function. So remember that we talked in statistical methods about how when you write down a function, you specify its input domain, its output range, and then you specify some names for the inputs and some names for the outputs, and of course you define how the outputs are computed from the inputs. And exactly the same logic applies to functions in programming. So functions can take in arguments, and which are called input arguments, and return arguments which are called output arguments. And inside the function, there are some computations or some statements are executed that somehow relate the inputs to the outputs. Maybe a difference to mathematical functions, programming functions don't need to have inputs and don't need to have outputs. So you can also write a function that just gives you some outputs without taking any inputs. And you can also write a function that takes some inputs but don't return any outputs, but does something else, for example, save data or something. But in general, it's advisable when you think about programming functions to think about also mathematical functions, specifically with respect to the inputs and the outputs. So to show you a first example, I'm just writing down a function. So and then we look at it closer. So functions are saved in MATLAB as M files. It doesn't make any sense to write a function into the command window. So you want to save them as M files. And what you need to specify is this function command. And then you can specify output arguments. So for example, fx should be an output argument. These square brackets you actually need when you have multiple output arguments. If you just have a single output argument, you can also go without the square brackets. And then the function needs a name, and I'm calling this function here fun for this function. And then you specify the input arguments. And then it makes a lot of sense to end the function with an end. Then you get this kind of bracketed thing here, and you can also close this, so then you see that you don't see anything, and you can expand that and see what's going on. And then the next thing that so this is called the function declaration line. Talk a little bit about that later on. The next thing that then is important is a function's help. So remember that, for example, when we looked at subplot, or two things. So we can type something called help subplot, and what this returns is actually the stuff that is written in the subplot function as the first block of comments. So if we look at the subplot function again, you see that there's this first block of comments. This is then what is displayed as help. And you can write your own stuff for that. So where are we there? And this is actually more than the code that you actually write. I think writing proper help and documentation for functions, this is really essential to use functions in a good way. So for this example, we have the following. This MATLAB function evaluates the mathematical function, which I'm now writing down. So it should evaluate the function f, which takes in a real number, for which I just used the r here, and maps this onto another real number. The input argument I call x here, and this is mapped onto the output argument, which I call x, and is defined as x squared. Yeah, so this is just x. Without this, it's just x squared, as you know. So you can square a real number and get another real number. Actually, you always get a positive or zero real number, and this is what you're familiar with from statistical methods or math, essentially. So this is the domain, this is the range, and using R to denote the real numbers. So if you're more into LaTeX, you might want to call that like this. So who of you knows how to write LaTeX code, by the way? Learn LaTeX and write your thesis in LaTeX. It's much better. So that's the domain and the range, so the real numbers, and then input argument, output argument, and what it does. So far the help says that this MATLAB function evaluates the mathematical function f, and then what you should always document for your MATLAB function is the inputs. So what does it take in? and in this case it takes an x, but you should document what that is. So you could say, for example, a real scalar, or if you're more into programming language, you could say scalar, for example, double, to basically give the, or float, maybe even better, to give the idea of a real number in programming terms. And then you should also document the outputs. And this in this case would be fx, and this would also be a scalar, so be a float. And this is essentially what you have written here in the declaration line already, but you now give it some more meaning and some more documentation. So just now that you're learning programming from scratch, whenever you specify a function, write the function help and the documentation of the inputs and the outputs first, and then write the function code, which is also called the function body. So then you can also put in that you wrote this, which might help you in lawsuits against your supervisor. Because your supervisor will claim that you didn't write anything and it was all given to you, and then you say, no, look, there's my name in there. That's a personal story, which I might expand on once we talk about open science. And then the next thing after this help and this essentially the header of the function, you actually now want some code. So you want to evaluate the function. So you see that you pass in some variable x, which you can now do something with, and you need to specify this output argument. So if your function doesn't specify your output argument, you get an error. So this is what you see here, where MATLAB gives you this warning that the function return value fx might be unset, which is not good. If you leave it unset, you will get an error when you execute this, and the input argument x might be unused. So far I'm not doing anything with it, but now I'm doing. I specify what I specified in mathematical or theoretical terms here. I'm saying that fx is set as x squared. Yeah? And that's all this function does. So let's save this. So now what can you do with a function? Well, you can call it. And so now what I'm doing is I'm putting this function that we just wrote as a sub-function into another function where I don't specify any inputs and outputs. So this is essentially what you would call a script. And in this script, I specify a value for x, like this. And now I'm using the function that I just wrote to apply what the function does to x. Yeah? So here I'm calling this function now, yeah? And you call functions in MATLAB by their name. So this is the name of the function. And you pass input arguments. They actually don't need to be called like the input arguments like you call them here. So another way to do this is actually to do it like this. Maybe that's even clearer. So I'm specifying a variable a here, which I set to 2. And then I pass this variable a into the function, which then, so by writing this, the function knows that the input, so once the code gets here, that x is supposed to be this, and then I'm getting it back. So let's have a look of what happens. And one thing that I like to do is to use keyboard, as you've seen previously. So now let's dock this again. And clean up a little bit. So now what happens is this code was executed, so this function example. So it first cleaned the screen, then defined a as 2, and then called the function ffun, which was specified here as a subfunction. And once this was called, a, so the value that a takes on, was passed into this function, and inside this function is now called x. What is really important here is that anything that happens outside of the function, once you are inside the function, is not there anymore, so you don't see it. So you see only the local space of the function. So for example, you don't see that it was called a previously, and if there would be other variables here, you would only now have access to the variables that you pass into the function. And then the function executes its code. So we can maybe look at that if we go one line further and run this function example code again. So now we are in the function after fx was evaluated, so we have x and fx. We're still locally in that function, and once we get here, this function was executed, a was put in, a was squared, and then this value that the function returns is b, and that now contains the squared values. So here we have a and b is 4. Yeah. So this is one way to use functions as a subfunction. Another way one can use function and define functions is to actually give them their own M file. So now I'm specifying an own M file for ffun, where there's nothing else in there. So in this case, so here you see ffun now, so we can look at the help. So we get what I wrote up there. Actually, this we might want to put one below, so oops, not run it, but so that it looks a little bit nicer. As you've seen, what I just did is, so for example, if you now call this function just like this, because I didn't specify an input argument, this function does not run. But also in this way, we can MATLAB looks whether there is some subfunction called ffun. If there's no subfunction ffun, then it actually looks into the current working directory whether there is some M file called ffun, and if there is, it uses this as the function. So this is also how you can specify functions in terms of their own M file code. I'm going back and forth between using subfunctions and using this kind of implementation of function. I think for these really small examples here, I think it's easier to have the subfunction inside the main script, because then it's easier. One doesn't need to open different files. So. Good. So this is a very basic example for using functions and specifying function. And of course, the idea is that you put into functions operations that you want to use repeatedly and which are a little bit more specific. Of course, you can implement the squaring of x also just by putting up by writing a square here, does the same thing, but of course it's an example to show what functions can be used for. Now maybe a little bit more about the details of functions, but first questions. Do you have any questions about this example? Yeah.
So it doesn't matter whether you put keyboard in the first function or the subfunction?
Yeah, keyboard. So this always stops the execution of the code where the keyboard command is. And so maybe also to make this local thing clearer. So if we have additional variables here, right now there is no keyboard in the f-fun, so the keyboard only stops here, and what we can see then in the workspace is everything that is defined within this function. Now, if we put a keyboard into this thing here, and run the code, then the execution is stopped when you are inside the function. And the nice thing is that you're now only seeing the scope or the workspace of this function. So you don't see, so these variables x and y and a, they are not passed into the function. The only thing that is passed into the function is a, essentially, and a is called inside the function. It's called x because it's the input element. And this is the only thing that you see. So the function now, if you write some code in the function, the only available variables to the functions are the one that you passed in, which is good because it's shielded from basically confusion that you have certain variables in, of course, a more elaborate script that you don't want to confuse with variables inside your function. So of course so this is kind of the local variable scope of a function. Other questions?
So one function that we define in an M file, can we access it from another M file?
I did that, right? So I had the function in the M file, and if it's in the working directory, so in the current directory, then you can access it. If it's not there, but in some other directory, this directory needs to be on the MATLAB path. If you have a function f, maybe let's make that clear as a example. So let's write this function as an M file again. So now there are no subfunctions, but I can run this code and it knows that f-fun is there. So maybe let's go to keyboard. So this works because this M file finds this f-fun as a M file in the current working directory. Now if I put this function somewhere else, which is the case, for example, if you download a toolbox like SPM, you will not always work in the SPM folder. Then this doesn't work. So now this function example, when it calls fun, doesn't know what that is, and you get this undefined functional variable fun. However, if you add this directory onto the MATLAB search path, for example, by right-clicking and then doing selected folders, then you also change that, see that it changes its color. Then this works again because MATLAB now also looks into this folder, which I called old, and finds in there this fun. Yeah? That's the MATLAB part business. So let's remove this again. Other questions? No? Okay. So maybe let's have a look a little bit more at the general outline of a function. So the first line is the function declaration line. Actually, if you you can open in MATLAB a new script or a new function. If you open this as a new function, MATLAB creates for you this function declaration line where you have the output arguments, you have some function name, which is the M file name of your function, and you have some input arguments, and then it also gives you, already puts up something for the head file. Yeah. So function names, what you can put here, there are some limitations, so I don't think that you can have empty spaces or free space in function names. So this is this is not a proper function name, so it needs to be a single array of letters or a single string, your function name. Then there's, I guess there's a maximum size of having up to 63 characters. You don't want to use more, and it's case sensitive, I think. So let's it's definitely case sensitive. So if we, for example, call here something called ffun, and we call, this is something to get used to, the way the function is called is by means of its M file name, not by the name of the function that you specify here. I will show that in a second, but first let's look at the case sensitivity. So here I'm now calling a function that is called big F fun, and this gives an error because it cannot find an exact match for F fun. But MATLAB has also improved, and it figures that there is something called ffun with a small f, and says maybe you wanted to use this one. Yeah? So it's case sensitive, the function name. Now the other thing is that if I call it ffun in here, that will still not resolve the problem, as you will see. Because MATLAB looks for the M file name, and it actually here tells you that the function name f, also capital F fun, is known to MATLAB by its file name lowercase f fun, and then you can always, with right-clicking, rectify that and give the same names. But the important thing, if you have functions as M files, is the name of the M file, not what is written up here. Okay, so that's about function names. Then with respect to a function's help text, I think there's a little bit of a difference between the first commented line and the rest. And this H1 line is identified by the look for command, but this is really not important. So the sometimes you see, that actually if you, it used to do that. So sometimes you see that the first line of comments is actually looking like the function declaration line. That used to be was supposed to be helpful, but I mean, just when looking at the M file or the subfunction, you see exactly what is written in this first line of comments in the function declaration line. So this was always a little bit redundant, so they don't enforce that anymore. And yeah, you're essentially free to write your help file or your help text here. Yeah, I don't think I want to say much more about the help text. The only thing that I want to say is that you should always write it. So whenever you specify a function, write a help and write it first, because the help also clarifies in your head what this function actually is supposed to do. So of course, so often you start programming and you don't really know what you want to do, and then at one point you get lost. And if you first specify what your function actually is supposed to do, then once you have clarified that for yourself, then writing the code is just technicality. You just need to implement what you want to do, but knowing what to do, that's more the problem. So please always write your help text first. Yeah, then with respect to a function's body, this is where the statements come in. And of course, you don't need to have a single line of function body, but you can use all sorts of code there. Of course, you can use for loops, while loops, you can come up with arrays and so on. So functions can be, of course, quite long. So maybe I show you a function example. If I find some SPM distribution here. So SPM is nothing but a big collection of functions. And oh, look, SPM bits, that's maybe something that you want to learn about. This, what does it do? I mean, we can see here, pass directory format according to the bit standard. And then you see that this code, that there's a lot of code that does a lot of stuff. So you don't have necessarily single line functions all the time. Yeah, so anything goes. So what do we have here? SPM base 2, compute and write log base vector image, and you see that there's a lot of code. And the nice thing about SPM is, of course, is that you can look at the code, unlike other software solutions where you cannot look at the code. Cannot look at the code. Good. There are like 3 commands that can be helpful in functions. So one command is, maybe I want it again as a subfunction actually. I like that more for these small things. So now we're back at the subfunction style. So there is the return command, which once the return command is reached, it returns control. It stops execution of the function. In this case, this will actually not work as I just wrote it there, because then fx is not set. So here you see the again error because fx was not set. So let's close this. So maybe as an example, if we have fx equals x here, then this bit where the squaring is carried out is not carried out if the return statement is here. And so now our b, when we are, let's get rid of, when we are here, for b, oops, where's b? 1, 2, 3. That's interesting. There was something else. So b remains 2 because the function returns already at this point. So that's one command that sometimes can be helpful, but yeah, essentially if you want to stop the execution of the function earlier, so for example, you can think of an if statement. So for example, if you only want to square values, that doesn't make sense. So return can be useful sometimes, but you don't have to do it, so you don't have to write return so that the function returns something. Another thing that you can do is, for example, use error commands. So, for example, if x is 0, you can stop the execution of a function and give some comment on that. So what this does is, now if I pass actually 0 to this function, then you get an error. This is sometimes helpful if you have more, of course, if you have more complex functions and you want to make sure that everything is working as it should, and you don't trust your code that much, and you want to make sure that if something goes wrong in terms of how specific variables are defined, that then you actually get an error. You can also do that more, and then the execution stops. I think you can also do that more, not that harsh, so that the execution is not stopped, but at least you are told that something is going on. So warning x should not be 0, but the function is executed anyhow. So you see warnings sometimes when you run SPM, and then you also always don't know what to do because it says warning, something is horrible wrong, but you still get a blob on the brain. Then the question is, do I trust this blob on the brain, or was something horrible wrong? Okay, I don't think so. I really don't think I want to discuss var arg in and var arg out because I don't like them. You see them, so the reason why you would be interested in var arg in and var arg out is because you might see that in SPM code or some other code that you download. So var arg in is about using a variable number of input arguments. Yeah, so variable arguments input, which basically allows you to call a function either with one argument, or with two arguments, or with three arguments, or different forms, so that you don't need to that you essentially go away from specifying exactly how many arguments you want to put in, and you can call the function with different numbers of arguments. I don't like this because it makes things less precise. So if you have a function, and then the function should take a number of arguments, a specific number of arguments, and give you a specific number of output arguments. And you can sometimes you try to write more general purpose tools that work with different numbers of arguments. I just don't like it. I mean, this is what we also have seen this morning when we computed, for example, mean. So if you think of back of what we did, so if we have something like this, then we could call mean like this, so with no input argument, or we could call mean like this with one input argument, maybe even more. Does that do anything? No. Anything? Nope. Option must be so, but you can actually put in a third input argument, so you can call the function with multiple input arguments, but I really don't recommend to do that when you write your own functions. What I recommend though is if you have multiple input arguments, and this is what I meant this morning. So for example, if you have input arguments, I don't know, monkey, kangaroo, elephant, snake, tiger, cat, dog, and sausage. If you have these input arguments and you call the function with these input arguments, of course you would need to specify what's going on. Then these expressions get quite long, and then you, for example, if you specify numbers for all of those, then you would have, if these are all scalar values, then you would have something like this. And then it's quite easy to lose track of which numbered maybe I should tell you that before. So if you have multiple input arguments, then if you call it, it's about the order of these. So the variable monkey would be assigned 2, the variable kangaroo 3, variable elephant 1, and so on. And that gets somewhat unhelpful. So a nice way to deal with that is actually to, if you have multiple input arguments, is to use structures for that. So let's call this f input, and then you might want to initialize this structure, and then you define for the structure and then stopping here. So I'm using something with 3 input arguments. And then you can call a function with just a single input argument. Of course, now you need to make sure that or need to account for the fact that the input is a structure, so you would have to change all your help here and document what the input things are. But then you can call this function, have the structure inside, and then can extract the things again, and you don't have these many input arguments. That's some way to organize your functions. But I think this will only make more sense to you once you write complex functions that might even take many input or output arguments. Yeah. Then, questions about this right now? No. Good. So then maybe let's talk about global variables. To tell you about something that you shouldn't use because it beats the purpose. So in principle, the variables that you have available inside of functions are those that you pass in, yeah, but nothing else. Yeah. Only x gets passed in, and that will be seen previously. Here, y and whatever else you have does not get passed in. Now, for some reason, you might want to have some variables that are defined in the code where you call the function, also in this function, but you don't want to pass them as input arguments. For example, because you want to limit the number of input arguments, or these are variables that are very general, and you want all functions of your programming project to have access to these. So this is when the idea of global variables can be used, but I advise against it. So never use global variables. I'll show you it anyway. So what you need to do is to specify a variable is global. So you need to write something like this, global y. So now y is a global variable. Let's call that different. Maybe you can remove it. So now to this global variable I'm assigning the value 10. I'm still interested in calling this fun. But now I want to pass in this global variable into the function, but not as an input argument. So what I can do is write here global y. So it's not an input argument, but by this, maybe because I want to add it here, I get this variable y into the function by basically not putting it in via the proper way as an input argument, but by slipping it through using global variables. So let's go here. So now we have in the workspace both x and y came in as a global variable. But the thing is, that's not, so I don't like it. So the if y is essential for the function, then it should be an input argument. So you could, of course, specify it like this. And would, of course, need to change your documentation here. And then you, of course, need to also pass it in there, but you don't need to define any global things. So if you run this, you again have both of them in there, but now you wanted them in there because you want to do something with them. So you can get it in there, and this global variable thing, why would anyone use that? Yeah? Sometimes you see it. Do you have a good reason to use global variables? No, they're just annoying.
Just dangerous.
Yeah, they're just dangerous, exactly. So don't use global variables. It's like while loops. Now, but while loops you actually sometimes really need, but global variables I don't think you ever need. Of course, somebody will have a good reason to use global variables somewhere, but in general, it's it's not worth the effort. Good. All right, so then I think as a last example for functions, I want to talk about function handles and anonymous functions, and show you a typical example where you actually use those. So the motivation, maybe we start with the motivation. So often once you do cognitive modeling, you want to do maximum likelihood estimation, or maximum likelihood estimation. And you know that if you maximize a function, it's the same thing as if you minimize a function, and then the negative of that function, and then somebody will tell you in MATLAB there's fmin search, which we can now look at. So fmin search is a function that uses this Nelder-Mead optimization, which is a derivative-free, unconstrained nonlinear minimization routine, and can be used to find the minimum of a function. So you want to maximize the log likelihood, or the likelihood, so you can minimize the negative log likelihood using fmin search. And this is what psychologists, specifically, so people that think they do modeling in psychology, they will fairly, once you meet them, they will say hello, and the next thing they will say, you can use fmin search. And the thing is that it's all fine, but to use fmin search, you actually need to be familiar with anonymous function or function handles, because fmin search finds the minimum of a function. So you somehow need to pass the idea of a function into a function. So fmin search is a function, and now you want to put in a function into a function. And this needs to be done in MATLAB using function handles. And this is what I want to show you now, and also show you how you then can use fmin search in this sense. So let's start a new script. I wonder whether I want to use a log likelihood example. Why not, actually? Let's see what I can, whether I'm able to do a log likelihood example on the fly, because we talked about log likelihood also the other day. So this is a factor in the context of having fmin search for maximum likelihood estimation. So this ties it in with the other course. So let's do the typical thing. We sample some normal data. I think we should have a break. Let's have a break for like until for 50 minutes or so, and then I show you with a little bit extended way compared to what is in the script, how to do log likelihood estimation. Yeah. So we're using if and such. So let's have a break until 2:15.